Hello everyone. Let's talk about bronze bushings. Bushings like these are in a lot of different types of machinery, and they're very easy to make, and for me anyway, they're a pretty common job. I have to make 4 of these little guys for a paint shaker that a friend of mine is restoring. The part they fit into slides back and forth on a pair of parallel rods. The outside of these have to be quite accurate. They need to be a press fit into the bore of the mating part. The inside, however, can be a rather loose slip fit. Making these too tight of a fit on the inside actually could make them bind in the way that they're being used. There's going to be a bushing made for each of these holes, and those slide over the 2 parallel rails. There's a second half of this as well, and it holds the paint can by just squeezing it in between and closing together. Then there's a screw with a right and left-handed thread, so when the handle's turned, it squeezes the 2 halves together, and then you can shake up the can. The bronze that I'm using is 932 bronze, and that's your standard bearing bronze. It's available in a lot of different shapes, but most often I buy it in bronze tubing, or cord round as it's sometimes called. However they list it in the catalog, you should know that it's always undersized on the inner diameter and oversized on the outer diameter. Nominally, this is 1 inch by 3/4 tubing, and when we actually do the measurements, we're 40 thousandths large on the OD, and on the ID we're coming in at 699, so 51 thousandths undersized. They sell it this way so you have room to clean up the OD and ID and actually get it to size if you needed a 1 inch by 3/4 inch bushing. This is also good because concentricity of the bore and the OD is not guaranteed. What I'm going to do for these is have it sticking out far enough that I can turn the outside and bore the inside and make sure that both of those are concentric, and then I'll part them off. Ideally, you really want to do bushings like this all in one operation to guarantee concentricity between the 2 features. I'm going to use the original part to gauge how much material to have sticking out of the chuck. I use this technique a lot because it's pretty reliable. You never want to have too much material sticking out of the chuck because it could be floppy and flex out of the way, but you also have to be wary of having too little sticking out. You have to be able to get all of your machining done and fit all the tools where they need to be, and in the case of the parting tool, it can't get that close to the chuck. Like pretty much any lathe project, the very first thing I'm going to do is touch off on the end and make a facing cut. This is going to establish a 0 that I'm going to need for my length. At this point I'm going to set 0 on my digital readout, but you could also use a dial indicator or your hand wheel dials if you have them. Likewise, I need to establish 0 on the diameter, so I'm just going to touch off on the outside, move in a little bit, and take a light cut. Once I get this cut done, then I can take a measurement and I know exactly where the tool is in relation to my part. As you can see, bronze forms these tiny powdery little chips, and that's because it's a continuous cast product. It actually machines a lot like cast iron, although it is nowhere near as messy. It is, however, going to throw these powdery little chips all over your shop, so it is pretty messy in that regard. As far as machinability, bronze is pretty fantastic. It's very forgiving, and you really have to do something pretty stupid to get a bad surface finish. I want to get a really good idea of how big the mating holes are, so I'm going to be measuring them with a telescoping gauge. I'm going to measure them in several different locations, turning 90 degrees each time, and then going further in, doing the same thing. That way I get a really good roadmap on exactly how big I need to make these bushings. I'm also not under any illusions at all that all of the holes are going to be the same size, so I'm going to measure every single one. With press fits, you really don't have that much wiggle room, so you need to make sure that everything is exactly right. After I got everything measured, I went ahead and labeled each hole with the extreme ends of each measurement. So I took 4 on each hole, and I just put the highest and lowest on each one. There's not much variation between the holes on each piece, but there's a lot of variation between the 2 separate halves. This means I'm going to have to make 2 bushings one size and 2 bushings at the smaller size. When I run into situations like this, I always go ahead and make the larger piece first, because if it goes undersized, I can always go ahead and make it into one of the smaller sizes. It's not as easy to make things bigger. Like pretty much every project that I do, the first thing I did was take a light cut and a measurement, and then I can plug that dimension into my digital readout. This is one of the many ways that digital readouts make lathe work a lot more productive. Since I have the diameter of the part plugged into the digital readout, I can move within striking distance of the final diameter and then take a last measurement. Or in cases where the diameter really doesn't matter that much, I can just move straight to the target dimension. In the cases of press fits, though, you need to be pretty spot on. If the part's too loose, it'll just fall right through, or will be too light of a press fit and work its way out. If the part ends up being too large, it could crush the bushing or break the part that it's being pressed into, especially if it's a casting. Of course, if the part is incredibly large, then it won't press in at all. As you can see, I've been taking measurements along the entire length of the part and at different spots, turning the mic 90 degrees. That's to make sure that I'm getting a really good picture of the diameter. In a lot of instances, especially in thin-walled parts like this, you can get a fair amount of taper and flex, and you want to know where those things are actually happening so that you can adjust accordingly. For press fits, I generally aim towards the high side of what would be a good press fit. That way, if I end up a little below where I was aiming, I'll still probably be okay, and I can always make adjustments with sandpaper. Yes, I said sandpaper, damn it. If everything is good on a part, but just one little bit of it is a little bit too big, then sanding will absolve you of all of your multiple machining sins. So how much is the proper fit for a press fit? That depends a lot on the size. If you were to try to leave 1/1000th of an inch on something that was only 1/8 of an inch in diameter, that would probably be too much. You might bend the pin that you're trying to press in. On the flip side, for larger parts, 1/1000th of an inch may be too little and it may not hold. There's also the question of materials. In metals and things that are really rigid, you can leave a tighter tolerance, whereas in plastics and things that are more flexible, you actually have to leave more interference, otherwise the part could just slip right out, especially in slicker plastics like Delrin. As a general rule of thumb, anything below 1/2 an inch or 12 millimeters, I'll use 1/2,000th of an inch for the press fit. Anything up to an inch, maybe 1.5 inches, I'll use 1/1000th of an inch. And generally, I'll add 1/2,000th per inch of diameter after that. This will get you in the ballpark, but there are an awful lot of variables at play with press fits, depending on how tight of a fit you want. So when in doubt, consult Machinery's Handbook. Now this was the first part that I did, so I actually took a little bit more care on this, and I think you always should. You want to make sure that you know exactly how the machine is behaving and how the material is behaving. So in this case, I took 2 finish passes. The first one with the measurement, so I know exactly where I landed, and then the adjustment pass, which I'm measuring for now, just to make sure I am where I'm supposed to be. The next thing I'm going to do is cut in a slight lead in. This is where I dust off a little bit of material just to make it undersized, and I'm going about 1/4 of an inch or 6 millimeters back. This is going to make it so much easier to press this bushing in straight. This is absolutely crucial on a thin-walled part like this, which could easily get crushed under the force of a hydraulic press or an arbor press, or even a bench vise if you're using that. Another good practice is to take a file and round over the edge of the part just a little bit to make it easier to start in the hole. The next part is all about boring out the inside. Like I said earlier, this can be a much looser fit. We make a lot of bronze bushings for large sump pumps at work, and those are quite often about 10 to 15 thousandths oversized on the bore, just so they don't bind when they get all put together. Ultimately, the size of the bore depends entirely on the application that it's going in. Like anything else, you've got to get a good measurement on the inside, and again, I'm using telescoping gauges for this. If you're not sure how to use telescoping gauges, I actually have a video on that, and I'll put a link right up here in the corner. Once all the boring is done, it's time to part off the piece, and I'm finding the edge of the parting tool by just putting a straight edge up against the end of the part and wiggling it back and forth until I feel it catch the tool. That way I can zero the digital readout there, and I know that's where the end of the piece is in relation to the parting tool, and I can move in. In this case, the length of these doesn't really matter very much at all, so it can be off by 10 or 15 thousandths either way, and this method is more than good enough to find the edge of the part. When I'm parting off hollow pieces, I will usually put a piece of rod into the drill chuck in my tailstock and slide it forward. This way, once the part comes separate from the parent material, it's not just going to go flying all over the place and ding off the ways, maybe end up across the shop. This is just one of the many simple tricks that you can do in parting to make your life a lot easier. Once I've started to make the cut as well, I'll usually come in with a file and deburr that edge before it gets parted off, because it's a whole lot easier to do it now than afterwards. The parting tool I'm using is actually just a high-speed steel blade, and I've ground an angle on the end, so as it cuts through, it will part off on the free side first and leave the burr on the parent stock. This just leaves a small burr on the inside of the bore, which is very easily taken care of with a regular deburring tool. Here's a close-up of the parting tool so you can hopefully see that angled cut on the end. Once all the deburring's done, I just need to repeat this process 3 more times. Since I'm making 4 of these bushings and all of the holes are slightly different sizes, I want to make sure that I don't mix up which bushing goes where. With that in mind, I'm taking everyone's favorite permanent marker, and I'm just marking each bushing individually. Since I got all of the measurements nailed down on the first one, I know how the machine's behaving, and on the subsequent bushings I'm just plowing right through the material. Now this is a close-up of the really horrible finish I got on this roughing cut. The thing about roughing cuts, though, is that the finish doesn't matter. What matters is plowing off the material as fast as you possibly can, and then you slow down on the last cut. There's no sense whatsoever in worrying about the surface finish on those intermediate cuts when the only one that matters is the final one. The original bushings had a hole in them, and I'm setting up to do that right now. I don't believe that hole was actually used for anything though, because there were no ports for oil or grease. Regardless, I have a table stop set up so that I don't have to locate each part individually. Now, this is a really quick and dirty job, so I'm using the scale trick to center the drill over the part. If you don't know how the scale trick works, you just put your machinist scale under the drill and you can see when it's off center, it's angled slightly. So that side's lower, this side's higher. Then you just move the table until the scale flattens out. Once it's nice and flat, and you can use the vice jaws to gauge that, you know that your part is roughly centered underneath the drill. Certainly good enough for something like this. Now I've got everything relatively centered, and I have the fixed jaw location and the table stop location found, and I just need to make sure that I put the lead-in area right here against the movable jaw, and everything's going to be oriented the same way. The drill bit that I'm using for this is one of my brass drill bits, and I've showed these off in a couple of videos. Basically, the cutting edges have a flat ground on them, which reduces the rake angle down to 0. That's great for grabby materials like brass, bronze, and sheet metal, because all of those materials tend to grab as the drill starts to break through, but relieving the tip keeps it from augering up the drill and ripping out of the vise. Now it's just a matter of pressing in all of the bushings, and I'm just using my arbor press for this. I'm putting a piece of scrap aluminum on top just to make sure that I don't damage the top of the bushing, and then just press it in until the aluminum hits the top of the casting. So there they are, all pressed in. Just have to do it to the other piece as well. I hope you found this video interesting. If you did, please consider hitting the like and subscribe buttons down below. And while you're at it, go check out my new Patreon page. The content on YouTube isn't going to change, and it's going to remain free. Everything on Patreon's just a donation. But I'll probably put some Patreon exclusive videos like gag reels and outtakes and things like that, and I might do the occasional giveaway of something that I make in my videos. I'll put a link to it down in the description. If you have any questions, comments, or jokes about elephants, leave them down below in the comments. Thanks for watching. I'll see you next time.